If I put a cup of boiling hot water and a cup of freezing cold water into the freezer at the same time, which one turns into ice first? Common sense says the cold one. But physics? Physics says you're wrong. It's called the Mpemba effect, and it breaks all the rules. This phenomenon wasn't discovered by a guy in a fancy lab coat. It was rediscovered by a high school student in Tanzania named Erasto Mpemba. In 1963, Erasto was making ice cream with his classmates. The fridge space was limited, and he was running late. Instead of waiting for his boiled milk and sugar mix to cool down, he shoved it into the freezer, piping hot. When he came back, his ice cream was frozen solid. The other kids' mixes, which went in cold, were still slushy. When he asked his physics teacher about it, the teacher mocked him, saying, "That is not world physics, that is Mpemba's physics." Well, joke's on the teacher. Erasto published a paper on it in 1969, and we've been arguing about it ever since. So, how is this possible? How does hot water overtake cold water? Scientists have three main theories. First, evaporation. Hot water steams. That means it's losing mass. Less water in the cup means there is less stuff to freeze. It's cheating, but it works. Second, convection. Hot water moves around a lot more. These currents circulate the heat, moving the hot water to the top and the cool water to the sides faster than in a stagnant cold cup. But the coolest theory involves hydrogen bonds. Imagine the bonds between water molecules are like rubber bands. When water is hot, those bands are stretched out tight with energy. When you suddenly cool them, they snap back together faster, releasing energy quickly, allowing the water to freeze at record speeds. Here is the catch. It doesn't always happen. It depends on the shape of the container, the purity of the water, and the exact starting temperatures. Physics is messy like that. So next time you need ice cubes in a hurry, try using hot water. Just don't melt your freezer shelf.